Alright, I left off the first video after solving this system by substitution. Now I'm going to walk through solving it by elimination and then also solving it using row reduction of its corresponding matrix. And so to solve this by elimination, I need to eliminate either this set of terms, the x terms, or the y terms. Now I could eliminate the y terms by multiplying this first equation by 2, so that then this would be 6x, negative 4y, and 10, and then adding it to the second equation, so that would eliminate the y terms. But what I've chosen to do instead is to eliminate the x terms by multiplying the second equation by 3. So that's what I've done here, is I multiply the second equation by 3, and that gives me negative 3x, positive 12y, and 15. And now I add that equation to the first equation, and so negative 3x and 3x gives me 0x. I didn't bother to write 0x, but that's what we have here is 0x. So the x terms are eliminated. And then I'm adding 12y to negative 2y, and that gives us positive 10y. I add 15 to 5, and that gives us 20. And we wind up with the same equation that we had here when we performed our substitution. And so I divide both sides by 10 and have y is equal to 2. Now at this point, the process is the same as it was with substitution. I can substitute this 2 for y into either of these two equations, and when I solve, I will come up with the same x that I came up with in performing the substitution method. I'll come up with x is equal to 3, and so we'll have the same solution. Now I will walk you through solving this by row reducing its corresponding matrix. And so we have a 2 by 3 matrix, or we will have a 2 by 3 matrix that is 2 rows and 3 columns. The 2 rows correspond to the 2 equations. The 3 columns correspond to the x values, the y values, and the constant values on the other side of the equal sign. So this first row becomes 3, negative 2, and 5. So there it is, 3, negative 2, and 5. And the second row will be negative 1, 4, and 5, which is what we have here, negative 1, 4, and 5. Now if you follow my recommended pattern, you will start by placing a 1 in the upper left corner of the matrix. And the way we would do that here is to interchange. Remember, this is one of the elementary row operations we're allowed to perform. We can interchange rows, and so I swap row 1 and row 2, and so this is the notation for that. So my row 2 is now row 1, and my row 1 is now row 2. And then I multiply the first row by negative 1, because that's what's in the that first entry is a negative 1. I need that to be positive, so I multiply negative 1 times that row, and that'll change the sign of this negative 1 to positive 1. So negative 1 times row 1 then is my new row 1, and again that's the notation for that right here. Now the next thing I need to do is get a 0 in this entry, because remember we're going counterclockwise around these 4 entries, and our next step is to get a 0 here. So that means I need to add negative 3 to it, and I use row 1 to get a negative 3 that I can add. And so I multiply negative 3 times row 1. That's what I'm doing here, negative 3 times the entire row 1. So that's negative 3 times 1 is negative 3. Negative 3 times negative 4 is positive 12. Negative 3 times negative 5 is positive 15. So now I then add that negative 3 times row 1 to my row 2. So that's what I've done here. Negative 3 plus 3 is 0. 12 plus negative 2 is 10. 15 plus 5 is 20. And so that then is my new, that becomes my new row 2. I'm placing that in row 2. And so this is the result of that. After having multiplied negative 3 times row 1 and adding it to row 2, I place it in row 2, and that is the notation for that set of operations. So now this is what my matrix looks like here. 1, negative 4, 5, and 0, 10, 20. And the next step in my process is to get a 1 in this bottom middle entry. And so all I have to do is multiply 10 times 1/10, and that will make that entry 1. And so there's the notation for that there. 1/10 times row 2 is my new row 2. 1/10 times 10 is 1. 1/10 times 20 is 2. And so I only have one step left, and that's to get a 0 in this top middle entry. Well, to get a 0 there, I need to add 4 to it. And if I multiply this 1 times 4 and add it, that will give us a 0 there. And this is why, by the way, that we want a 0 in this entry. We can now do whatever we want to this row and add it to this row without sort of bothering that 1 up there in the upper left entry. So I multiply 4 times row 2, because that's what I'm going to do, is add row 2 to row 1. So I multiply 4 times row 2, and so that's 4 times 1 is 4, 4 times 2 is 8. And so that 4 times row 2, I then add to my row 1, and 0 plus 1 is 1, and 4 plus negative 4 is 0, and 8 plus negative 5 is 3. And so I have a new row 1, so I'm going to place that in row 1, and so this is the notation for that set of operations. 4 times row 2 plus row 1 becomes my new row 1. And so now you can see that in matrix form I have the same solution to the system that I had when I used substitution and elimination. Now the next system is 3x plus y equals negative 3 and x minus y is equal to negative 5. And in this first column I'm performing substitution. By adding y to both sides, I isolate the x in the second equation. I could have isolated the y in this first equation, but I chose to isolate the x. So my new expression for x is y minus 5. And so I substitute y minus 5 for x in this first equation. Don't forget, again, don't forget your parentheses. You place this wherever you have an x, you put some parentheses, and inside that x you place this expression, x in terms of y, y equals 5, you place that expression, and now we solve for y. That means that we distribute the 3. 3 times y is 3y, 3 times negative 5 is negative 15, and so our new equation becomes 3y minus 15 plus y is equal to negative 3. I collect my like terms, so I have 3y plus y is 4y, and I add 15 to both sides of the equation, and so that's 15 plus negative 3 is positive 12. So I have 4y is equal to 12. I divide both sides by 4, and I have y is equal to 3. So I then substitute that 3 into this equation, because that's the simplest equation I can substitute it into to solve for x. And so y equals 3 here. 3 minus 5 is negative 2, and so x is equal to negative 2. So we can see that the solution to the system is x equals -2, y equals 3. Now to solve this system by elimination, since the y terms are already additive opposites of one another, I can just simply add the two equations together. So I add them together, and that 3x plus x gives us a 4x, and y plus -y gives us a 0y, so the y terms are gone. The -3 plus the -5 gives us a -8, and so when we divide both sides of this equation by 4, we get x equals -2. And with x equals -2, we can then substitute that into either of these equations here, and when we solve for y, we will get 3. Now I don't have those calculations represented here, but that is certainly what we will arrive at, is y is equal to +3. So our solution is -2, +3. X is -2, and y is +3.